Welcome students. In today's class I will explain to you this important question. Now the question says 5 raised to the power of x is equal to negative 5 and it expects us to solve. In other words, it wants us to find the value of x. Now on closer observation, what do we really find here? Now the problem wants us to find something which is quite contradictory. Now why do I use the term contradictory? Because on the left hand side 5 is being raised to x, where x can take positive number, negative number, or among positive negative it can be a whole number or a fractional quantity, right? Now no matter what the value of x over here, and when you substitute it over here, it is never going to be equal to the right hand side. It will never, the best way to put it like this, it will never yield a negative number, leave alone 5 or negative 5 in this case. You will never get a negative number. So that is the first and foremost observation that you need to make. Now clearly you know, because this is largely due to the property of exponential functions. So therefore the implication is there is no real solutions at all. That is the first point you will have to make. That's it. You don't have to do anything, right? Now what I wish to do is I would like to attack the problem from the complex analysis point of view. So let us find the roots in the complex realm. So in the real realm is not possible, so we go to the complex mode. So how are we going to handle this? This is given 5 raised to the power of x is equal to negative 5. I want to rewrite this as 5 raised to the power of x. Can I push? First let me write it as negative, okay, positive 5 times negative 1. That's a better way to write it. Next what I'm going to do is I'm going to push this down. So it's going to be 5 raised to the power of x divided by 5 is equal to negative 1. Next what I'm going to do, I'm going to push this to the numerator. So this is 5 raised to the power of x times 5 raised to the power of negative 1 is equal to negative 1. Now a raised to the power of m times a raised to the power of n is a raised to the power of m positive m. So this is going to be 5 raised to the power of x negative 1 is equal to negative 1. Now can I write negative 1 as 5 raised to the power of x negative 1 is equal to negative 1 positive 0 times I? This means this is of the form a positive ib, a complex number, right? So all of these are accepted. Now what I wish to do is I would foremost make a representation for the right hand side. Let z be equal to negative 1 positive 0 times I. So this means if z is a complex number of the form a positive ib, then I have the following. By Euler's form or representation of complex number, I can always write this quantity as z to be equal to r times e raised to the power of some I theta. Now you may be wondering, what is this? We have Z as A positive IB, and now this man is saying Z is equal to R times e raised to the power of I theta. How is that possible? Well, that is the exact form that Euler, the great Euler, gave us, where, let me write it down here, where R is equal to square root of A squared positive B squared. If we were to substitute the value of A, which is negative 1 squared, B is 0, so which is root of positive 1, which is equal to 1. That's the value of R. And theta is given as tan inverse of B divided by A. In this case, tan inverse of my B value, as I mentioned, is 0. My A value is negative 1, which is going to be pi. Fair enough, right? So therefore my Z is equal to 1 times e raised to the power of I. My theta is pi. Now comes the all important part. Now what is the all important part? I wanted to bring it to your attention. This is very important. Now most of the times the steps would be skipped in expanding this, or I should say in explaining this, but I am going to deal this in a little bit further for your understanding. Now this e raised to the power of I pi, now this is the Euler's form. Now if you have something like this, e raised to the power of I times x, then this can be rewritten as cos x positive I times sin x. Now e raised to the power of I pi is nothing but cos pi positive I times sin pi. Cos pi is negative 1. This is going to give me 0. So Z is actually equal to negative 1, which is what we started here. Okay. Now the question comes, is it possible for me to generalize? Right? How do I generalize the part here? So what I've got now, let me rewrite it here. So I now have Z to be equal to negative 1, which is equal to e raised to the power of I pi. Now we know that cos is a periodic function, and cos of 2 times pi n positive x is going to give me cos x, and sine of 2 times pi n positive x is going to give me sin x. Cos and sine are periodic functions. So what I wish to do is, can I write e raised to the power of I times pi, which is equal to cos pi positive I times sin pi, which can I write this as cos of 2 pi n positive, in this case it's going to be let me take this as x, so that I will have x there, e raised to the power of I times x is equal to cos x positive I times sin x, and cos x is periodic, so I'm representing it like this. So this is going to be I times sine of 2 pi n positive x. Can I write it like this? Because of the fact that we have got cos and sine to be periodic. Now can I rewrite this as e raised to the power of I times of 2 pi n positive pi for n element of natural I would say an element of some integers, for any integer, this is going to be holding good. So e raised to the power of ix, in fact this is going to be x here. Now if I were to rewrite it for e raised to the power of I pi, this is going to be, as I mentioned to you, cos of 2 pi n positive pi positive I times sine of 2n pi positive pi, which is equal to e raised to the power of I times 2 pi n positive pi. Okay, and n is element of integer, so this is going to be true. So now what have I done here? I have actually rewritten z equal to -1, which is represented as e raised to the power of I times pi, is now rewritten as e raised to the power of I times 2 pi n positive pi. Okay, now where did we find this quantity -1? Where did we get that? That is on the right hand side. And what we have on the left hand side? 5 raised to the power of x -1. So let me go to the next page. So I've got, of course, this question needs some explanation, so that's the reason. So this would mean 5 raised to the power of x -1, which is equal to -1, can be rewritten as 5 raised to the power of x -1 is equal to e raised to the power of I times 2 pi times n positive pi, where n element of z, right, integers. Now what I wish to do is I would like to rewrite this as ln, using ln of 5 raised to the power of x -1. This is to the, when I say ln, it's base e, right? Now can I raise this as an exponent for e? This base is e. What is this? This is nothing but rewriting this. Now we know that ln a raised to the power of b is equal to b times ln a. Excuse me. So by that fact I can rewrite this as e raised to the power of x -1 times ln 5. So take this and substitute. Let me take this as 2. So therefore 2 can be rewritten as e raised to the power of x -1 times ln 5 is equal to e raised to the power of I times 2 pi n positive pi, n element of z. Now you have e as the base, e as the base, so I can drop them. So this means x -1 times ln 5 is equal to I times 2 pi n positive pi. I need to get the value of x, so push this guy down. So this is I times of 2 pi n positive pi divided by ln 5. This is x -1. I need x, so x is equal to, take this one to the other side. So this is going to be I times 2 pi n positive pi over ln 5 positive 1. So this is the value of x in the complex world, right? It's a beautiful question. I hope you all enjoyed this. Please like, share and subscribe to our channel. Students, enjoy your day.